In the screencast, I'm going to show you how to use IODA's Explorer. IODA is short for Internet Outage Detection and Analysis, and we develop it here at CAIDA, a research center at UC San Diego. IODA continuously monitors the internet for outages and provides a powerful web interface to analyze these outages. There is a lot to IODA, but in the screencast, I'm focusing only on the Explorer, which is the most powerful and flexible part of the web interface. If you haven't already, you should first watch our screencast that discusses IODA's dashboard, because it discusses key concepts that we will talk about in this screencast. To access the Explorer, open ioda.caida.org. You can then click on the link in the menu bar at the top of the page. Note that you need an IODA account and be logged in to see the link to the Explorer. You can get an account by sending an email to ioda-info@caida.org. Once you're logged in, you will see the link to the Explorer and can click on it. We are now in the Explorer, which is very different from the dashboard, which you may know from our other screencast. The dashboard is meant to provide an overview of potential outages that happened on the internet over the last 7 days. The Explorer, in contrast, allows us to dig much deeper, both in terms of breadth and depth. Unlike the dashboard, the Explorer is not limited to 7 days. It lets us compose and contrast many time series, and it also allows us to transform time series. We will cover all these features in the screencast. There are 4 components in the Explorer. First, there's the main visualization panel, which by default shows IODA signals for the United States. This panel is very similar to what you already know from the dashboard. Then, like in the dashboard, there is an element in the top left corner that allows us to select a time period. Right underneath, we have a drop-down menu that changes the way our time series are displayed. You may also remember this feature from the dashboard. Finally, we can compose time series in the bottom left element. This feature doesn't exist in the dashboard. This tool allows us to add, delete, and transform time series, which is where the full power of the Explorer comes into play, as we will see in a minute. Let's start by getting a feeling of what we can do with the Explorer. By default, the Explorer shows IODA signals for United States over the last 7 days for the 3 IODA data sources. Each of these signals is a time series upon which the alias function has been applied. The alias function allows us to give a name or alias to a time series. Now, let us begin by focusing upon one of these time series, the darknet time series of the United States. We will delete the other 2 time series. We will also remove the alias function by clicking on the unwrap and destroy function. We will start with the darknet time series of the United States because it's a good example to analyze. You will notice that the visualization interface is quite similar to the dashboard. For example, it allows us to zoom in to inspect a time series closely. Now, let's add a second time series for comparison. Our current time series is shown on the left. It is identified as darknet.ucstnt.non-erratic.geo.neta.us.unique_source_IP, which is really quite a mouthful. IODA captures and archives thousands of time series and identifies them all by a string, just like the one we can see on the left. Let's add a second time series that illustrates the darknet data for Cambodia. To do so, select our current time series and then click on the clone button to duplicate it. We now have 2 time series that are identical. So let's proceed by editing one and making it display another time series. You can do that by selecting the time series and then clicking the edit button, which has a small pen icon on it. We now see a pop-up window that allows us to select what time series we want. The window is organized in a hierarchy. You can think of it as a file system which has directories and files. At the root of the file system, we can see IODA's three data sources: active probing, BGP, and the darknet. There are also directories whose name is just a star. These directories have a special meaning. They are placeholders for all other directories in the current directory. If you have a programming background, you can think of the star as a glob pattern. Now, let's find Cambodia. Basically, we select a time series by navigating down any of our three root nodes. We see that the node darknet is already expanded. Similarly, we can see that the node UCST network telescope is also already expanded. It identifies what darknet we're using, in this case, the one run by UCST. The next node, non-erratic, is also expanded. It refers to a cleaned version of our darknet signal. Next, we have the choice between geolocation and routing. Geolocation contains all time series for countries and regions, while routing contains time series for autonomous systems. Let's start with the country and open geolocation. Here, we want to click on Net Acuity. This is the name of a geolocation system which is more accurate than the alternative, which is MaxMind Geolite. Finally, we have now arrived at continents. We want to see the darknet time series for Cambodia, so we open Asia and then open Cambodia in the resulting list of countries. We now see in this node all of Cambodia's provinces, a glob pattern identified by a star which refers to all Cambodian states, and a leaf node which is called number of unique source IPs. Let's click on this leaf node which adds the darknet time series for all of Cambodia. We now see two time series, the United States as before and Cambodia. Both cover the last 7 days. The two time series are difficult to compare because the United States has significantly more unique source IPs than Cambodia does. To facilitate comparison, we can normalize the time series. This is another powerful feature of the Explorer. It allows us to transform time series in various ways. To normalize our time series, we first select a time series and then click the button that says f of x. Again, we see a pop-up window that shows us all functions that IODA supports. They are ordered by category and range from arithmetic to transform. The normalization function we are looking for is in the transform category. Here, we can see the normalize function in the middle. When moving your mouse button over functions, you see a short description of what each function does and what arguments it takes. Our normalize function takes one or more time series as input. Let's click on it to apply it to our time series. You will notice that the US time series turned into a flat line and is outshadowed by Cambodia. This is because the US time series now ranges from 0 to 1 and has significantly smaller numbers than Cambodia. Also, you will notice that in the time series composer to the left, the US time series is now encapsulated by our normalize function. To make the US and Cambodia comparable, we also need to normalize Cambodia. To do so, we can just drag the Cambodia time series and move it into the normalize function. Finally, our two time series are very similar in their range and are significantly easier to compare. They are now both in the interval ranging from 0 to 1. We can now see that both time series exhibit a daily pattern of peaks followed by valleys. This pattern resembles internet-connected devices being turned off overnight and on again in the morning. Let's now look at sub-country granularity. What does the darknet in the US look like for the state of California? First, let's remove Cambodia by clicking on the time series and then on the small trash can icon. Next, we edit the US time series by selecting it and clicking the Edit button. Inside the directory for United States, we find all 50 states. Let's navigate down to California, open it, and again select Number of Unique Source IPs. IODA supports sub-country granularity to find outages that affect only parts of a country. Let's now consider a different use case. We previously saw how to compare the darknet data of two countries when we compared the US to Cambodia. Often, however, we may wish to compare more than just two time series. Let's have a look at how all the continents compare. Again, let's click on our current time series and edit it. Now, we can make use of the star directory at the top, which is a placeholder, in this case, for all continents. Let's open it and click on the Number of Unique Source IPs field. We still have the Normalize function applied, which makes the resulting visualization a bit of a mess. Let's get rid of it by selecting the function we want to remove and then clicking the button that removes a function. As a side note, more experienced Explorer users don't have to use the buttons to compose time series. You can click on the link that says Edit in plain text and then compose time series in the small field that shows up. We are now back to absolute values, which gives us a better idea of how many unique IP addresses our darknet captures from all continents. We see the most addresses from Asia, followed by Europe. We can click on a time series to blend it out, which allows us to focus on the remaining time series. We can double-click a time series to display only the given time series and nothing else. At the top, the Explorer provides options to change the visualization. For example, we have the choice between a line graph, which is the default, and a stacked and a bar graph. By default, our time series are sorted by name. We can, however, choose to sort them by other criteria, such as maximum value. Another feature that can come in handy is to move one of our time series to a secondary y-axis. For example, we can click on Asia and we now see a secondary y-axis on the right, which is valid only for the time series for Asia. Note how we can now see an almost overlapping daily pattern in the time series for Europe and Asia. The time series don't overlap because the continents cover different time zones. Next, we have a drop-down menu that says Time Point Aggregation. To understand what it does, you need to know that IODA's data sources deliver data at 3 levels of granularity. Active probing yields 1 data point every 10 minutes, BGP yields 1 every 5 minutes, and the darknet is the most granular and yields 1 every minute. When we select a large time period in the user interface, IODA automatically reduces the granularity to make it easier to inspect large amounts of data. At the bottom of the panel, we can see the data resolution of our current visualization. It has a 1-minute granularity, but it is displayed as 5-minute bins. This is because we are looking at 1 week's worth of data. We can zoom in and see that the data points are 5 minutes apart. IODA took 5 data points and summarized them into 1 point. When we pick a time period of 1 day instead, we can see that the data points are now just 1 minute apart. The drop-down menu at the top determines how IODA summarizes these data points. The default is an average, but we can also choose other ways such as the minimum, maximum, or first value. The last UI element at the top is the y-axis zoom, which is set to auto. This means that we can only zoom in along the x-axis. If we disable the button, we can zoom over both the x and y-axis. Let's go over what the bottom of the visualization panel offers. You may be interested in working with the raw data that IODA displays. We allow users to download the raw JSON data for custom analysis. At the bottom, there is a button to both view and download the JSON data. Like in the dashboard, the Explorer also can be configured to display live updates, which is useful when keeping track of an ongoing internet outage. Finally, at the bottom right, there is a button that says Short URL. As the name suggests, it creates a short URL to send to others. Note that short URLs are only accessible to users who have an IODA account. We can also name the URL to make it meaningful. Finally, I want to show you that IODA's dashboard has a convenient button that takes you right to the Explorer to analyze a given internet outage. Now, let's click on the dashboard and finally click on any country in the alert feed on the right. We can see a button at the top right of the panel. When you click it, it takes the current visualization and moves you over to the Explorer. You can then add time series, transform them, and inspect time periods larger than a week.